Okay, so this one that I gave for you was a little harder than the one I did because you had to actually rearrange. So here, what's the partial pressure of oxygen in a scuba tank with a total pressure of 2250 psi if the tank contains the oxygen, nitrogen at 1755 psi, and argon at 22? Well, we know the total pressure is equal to the pressure of the oxygen plus the pressure of the nitrogen plus the pressure of the argon. So if I need the pressure of the oxygen, I take my total, subtract the pressure of the nitrogen, and subtract the argon. So 2,250 minus 1,755 minus 22 is equal to 473 pounds per square inch of oxygen. So very straightforward math, adding and subtracting. The biggest problem I typically see with these is when students don't read carefully and they don't answer the question. They calculate something else other than what's being asked to calculate. So I mentioned that we would talk about vapor pressure and Dalton's law of partial pressure when we collect gases over water. One of the things that we do quite frequently in the laboratory is to generate gases through some chemical reaction and then collect these gases, and we say we're collecting them over water or we're collecting them by water displacement. And so what we do in this case is we have some kind of chemistry going on in a flask, and this flask has some reaction that's making a gas. Now we have a little setup here. So over here I have a bucket of water, and I have a gas collecting bottle that is filled with water, and it's inverted into this container. So this starts off filled with water. Now we take the apparatus and we connect some tubing so that as the gas is produced, well, this tubing is usually more uniform in diameter than what I've drawn here. As the gas is produced, it comes through this tubing and it bubbles up and starts collecting the gas bubbles up here, and it displaces the water. And the water that was originally in the gas collecting bottle goes down into the bucket. And this is entertaining. When people do this the first time, they always fill the bucket right up to the top. And then as this water goes in the bucket, they end up with quite a mess as it's spilling over. So that's something to be aware of if you ever do this. Now, as you're collecting this gas, the gas up here now becomes a mixture of the gas that you're collecting plus water vapor. So we have gas and water vapor, and we say that we now have a wet gas. And we can use Dalton's law of partial pressure here because we know the total pressure, which is equal to the atmospheric pressure, is equal to the pressure of the water plus the pressure of the gas. Now, the pressure of the water is actually the vapor pressure of water. It's the vapor pressure of the water, and we can find this on some kind of a chart. So this makes it really easy to collect gas this way. We can look up on a chart and say, what's the vapor pressure of water at a particular temperature? And that allows us then to just get that information we need and to subtract. So we'll start here doing an example of this on Thursday.